Worksheet 4.4. Okay, so here we want to write down a function that can be used to describe the following rules. So what we're thinking, we've got our input going in, our function, and then our output. So to square the input, our function we can use will be y is equal to x squared. X goes in and comes out as x squared. To square the input and add 2, we're going to have y is equal to x squared plus 2. Square the input, divide by 2, y is equal to x squared divided by 2. To divide the input by 2 and then by 3 and then add 2, y is equal to x divided by 3 plus 2. Subtract the input from 7, y is equal to 7 minus x. And to square the input and add 2, x squared plus 2. Okay, so now for question 2 here. We want to indicate whether the following points here, sets of points, are relations or functions. So we know our function can only point from one point to another point here. So here we've got 1, 1, 2, 2, 3, 3, 4, 4. So this looks like this when we draw it. This one is a function. Here, this is the same one, also a function. So here we've got 3 pointing to 1. So if we actually plot this, so here x is 3, we've got here 1 and here's 2. We're going to have 1 point here and 1 point here. So there's 2 results when x is equal to 3 here. Our other ones seem okay here, but this one is not a function, it is a relation. So here we've got x and 3 for all real x, so our y is always on 3 here and our x here. So yes, we have a function. So on to our next questions here. Drag these down here. So now we have here, if we to draw this one up, we've got our x is equal to 3 and our y can be anything here. So we've got more than one output for our input there. So this one is a relation. Here, our next one, x squared plus y squared equals 16, is our formula for a circle here. So we're going to have 2 points, so this one is a relation. So our next one here, 9 minus x squared, square root of 9 minus x squared becomes a function. And x squared plus 2, also a function. So now we're looking at our domain and range here. We want to find the domain and the range of the following graphs. So if we look at our domain here. So our domain, this will continue down, here can be any value in our x. So our domain, we can call all real x. Our range, if we look here, our range, we can extend this way, but we don't extend past this point 3 here. So our range becomes y less than or equal to 3. So for question B, we look at our domain, and our domain starts here at -2 and goes through here, and we don't know. So this point here is also 2 here. So our domain is 2 less than equal to x is less than 2 here. Our range, when we look at it, here we're at 0 and here at 2. We're going to always be in this range here. Our range, 0 is less than or equal to y is equal to 2 here. So here for number 3, we look here, our range for our x, these continue on. We have no limits where we can go here. So our domain is all real x. Our range, we look at it again, our range continues down this way, but it stops here at 8. So our range, y is less than or equal to 8. So now for our next question, question 2. We want to know what is the range of the function whose graph is shown below. So here we're looking at, we've got two different points here, and we're going to separate it into its two different sections. So on this side here, this is our x is less than 0, x greater than 0 is on the other side there. So we say for x less than or equal to 0, our range becomes here is y that's greater than or equal to this minus 3 value here. We can continue up here. And on this side we're saying, well, here we're on the other side. So if we're saying for x is greater than 0 here. Now we look at our range, and our range is y is 2, isn't it? That's all we have is running along the 2 line. Y is equal to 2. So question 3, same sort of thing. We're splitting it into its two sides. So on this side, we're saying, well, x here is less than or equal to minus 2. And our range here, we start here and we're moving this way. So our range are all values here greater than 0. So on this side we're looking, well, we're between 1 and we have an asymptote here. So we're saying 1 is less than equal to, or x less than 2 here. And our range here will be all of our y values, y less than 0 here, because we're continuing in a negative way here. And we note our range is not valid outside of these numbers here. So it's not valid here and it's not valid outside of here. So outside of these ranges, it's not valid. Okay, so question 4, we'll just move these in a little bit. So for our following functions, we want to sketch the graph, state the largest possible domain and range here. So we're just going to sketch the graph here. So we know, well, here we cut through our x-axis, our y-axis at 7, and our x-axis also at 7 here. So this is our shape of our graph here. So here we know, well, our domain will be all real x. So here we can say, well, it's negative infinity less than or equal to x less than or equal to infinity. Same for our range. Here, minus infinity less than or equal to y less than or equal to infinity. So for our second graph here, 7 minus x squared here. So what we've got here is a parabola. We're cutting through our y-axis here at 7, and it's a negative. So we're having our parabola will go this way. So here our domain again will be all real x. So our domain is between negative infinity and positive infinity, all real x there. Our range, however, can't be greater than 7. So here we have our gx, or we can put it as our y to make it just a bit simpler to write. Our y must be less than or equal to 7. Okay, so for our third one here, what we have is our equation of the semicircle. We draw this one in, and so here root 7, root 7, root 7, this negative root 7, this is where we're cutting our y-axis and our x-axis here. So our domain is between negative root 7 and positive root 7 here. So here domain, negative root 7 is less than or equal to x less than or equal to root 7 here. So our total, our largest possible domain, will be 2 times root 7 here, which becomes 5.19. So 2 root 7 is our total domain here. Our range is between 0 less than or equal to y less than or equal to root 7. So here our range will be root 7 here. So this next one here is the other side of that same semicircle, but here on our negative side. So we'll just move our graphs up a little. Okay, so here, our other side of our semicircle, we have root 7, negative root 7, negative root 7 here. So here our domain will be, again, negative root 7 less than or equal to x less than or equal to root 7. So our largest possible domain will be 2 times root 7. Here is equal to 5.19. Our range is between 0 and negative root 7 here. Negative root 7 less than y less than 0 makes more sense there. So now what we do, our largest possible range will again be root 7 here. And for our final drawing here, we've got here y is equal to square root of t. We draw it, it's going to be like this. Here our domain is all t greater than or equal to 0, and our range, our y or our f of t here, also greater than or equal to 0.